Hi to everyone. Now it's time to implement physics in our Three.js project. In our Three.js projects using the library ammo, which is inside of the Three.js module when we are using Webpack. But the libraries of the ammo library are kind of hidden, so we need to copy from that place, the place where are they, to a place where we can use it in our projects, in our deployments. So in order to do that, we need to use a Webpack, a plugin, specific plugin of Webpack in order to copy those files. So that's why we are going to start with that step, and after that we are going to implement the library, and after we are going to make an example, hopefully in a short time. So at the beginning we can, as you can see, we can write this scene. We're copying this code. If you are following the tutorials, you can understand everything, or maybe you can do everything here and you can get the same result. So our first step is going to go to webpack, and then in the official website looking for copy file. That is the thing that we have to do, we need to do. Let me check this out again. Copy file, and if we go again, yeah, because I remember sometimes the searcher send us to almost the end of the tutorial we are looking for. So we need to go to the top where it says the name of the plugin, which is copyWebpackPlugin. So there we have our command to install this plugin. So if we open this up and we clean the console and we paste this command, we will see in our package.json we have now another dependency, which is copyWebpackPlugin, the version 9.0.1. So now we need to continue configuring, in this case in our package config.file, which is a configuration of the Webpack. We're going to drop the banners here, we paste that line, and now we copy the plugin part of the export JSON we have here. Now we need to looking for our ammo libraries files. So they are really hidden, so we need to go to node modules, then to Threejs, 3, then examples, then JS, then libs, which is a short way to say libraries. Click on it, and we have to copy the path of this file, the ammo.wasm, which means WebAssembly, which is a special technology that allows us run code in kind of binary code, so it is faster. And we need to copy the path of the neighbor file, which is wasm extension. Have that extension we need to fix because we are at the moment using Windows, the backslashes, and now we need to copy the names of those files. We will see after this that we will get those files. Let me delete this folder at the moment. We don't need it because it's recreated every time we run the command npm run build or prod yeah, build. Now we are going to get, oh, what happened here, npm run build. I missed the D at the end. Now we have here our bundle, the common one, and here in the output path we will get those files. So we don't need to write here this because it's going to make another subfolder, so you don't need to do this. So something that you can imagine is create here another script with that, just the library, the JS script. The other one is used loaded automatically, the WebAssembly extension file. So after we do this, we finish the configuration, but not the code configuration. So once we have done the when we have copied the files, we need to see in the official library how to use that library. So as I like to do, I like to go and see where we can find that information. Check this out. Go to the example, try to looking for Physic. You will see some examples. I suggest to you use this one, the cloth with the bricks in this arm. And if you're looking for the ammo on this source file, you'll see that it's loaded as we have done recently, and then it is implemented as a promise like here. So we will do the same. So we have to go to our entry file, which is src index, and we are going to wrap these two lines inside of the promise. We are going to wrap this line with the code we just copied. So after that, if everything is okay, the code is still running as usual, and we can check that library is uploaded. Let me refresh the code, the page, and here you'll see the ammo is loaded. So after that, this ammo is in the global scope, so we can use it from anywhere. So in order to continue with the implementation, now the configuration is done, 100% done. Now in order to code and use this library, we just can copy and paste a folder with several files that are generic or customized, but I am going to copy one by one module by one, because I think it's going to be better. So I will use the full screen. Okay, yeah, and then I will close everything, close everything, and we are going to create a folder named physics, and there I will put our first module, which is init physics, which have as a dependency another module named gravity. Let me copy that. You'll see it's just a configuration number. This file just build up a physics world which is not visible from us. So we need to connect the physics world, which is invisible, with the visible world, which is the Three.js world. So this is the physics world, is kind of the scene where we are going to put the physical objects in the following steps. The second part I like to share with you is a particular function that shows us how to create cubes in a professional way, or accurate terms is a paralellepiped, which is a funny name. Parallelepipeds. So in order to create parallelepipeds, shapes, we need a margin module, which is another configuration file. So I will close this one, You'll see did create the mesh, and as you know, with a geometry and a material, and we set the material in create the parallelepiped. You have to pass the material, it has a parameter, that's all. Yeah, this module create the shape, which is this one, and it is that we are going to return in case you need it. But it calls another function, which is create Rigidbody, which is this module. And create Rigidbody, take the mesh, copy the position and the rotation of it, and then use it to create a body, a physical body, not a mesh body that we can see, a physical that is going to be inside of the physical world that is not visible. So this body and the physical world is not visible. So in order to make it visible, we are going to link the physical mesh, the physical body with the visible, physical and visible, the visible body with the physical body using the mesh, and in that mesh we are going to use the user data, and we are going to create a specific property where we are going to place the physical world into the visible world, the physical body into the physical body. So that's why after that we are going to place the visible body into the scene, as you can see here. So Rigidbody is a funny, another useless module, because it's just an array. Oh no, this one, no, again I made the same mistake. Rigidbody, we are looking for the Rigidbody. Rigidbody is in plural. It's just an array. So if the mass is higher than 0, we are going to collect them in one array in order to after process all the bodies that have mass, just the bodies that have mass. If there is a body that doesn't have mass, for example the ground, it's not going to be moved because it doesn't have mass. Also, okay, because we will not move it if in order to keep it in the same place, just we set mass equal to 0 or lower than 0, and in the physical world is not going to move, never. In the visible, in the physical and in the visible world is not going to move, never. So when you put the mass, the higher mass, when you collision one object with other one, the higher mass is going to have more power with the lower mass, which is going to be weaker. So that's it. Practically we get the position and the rotation handled by quaternions, and we set it on a body. Here there are a bunch of configuration that we don't need to know, and we place the physical body into the visible body in the property user data of the Three.js mesh, in the property which has another property, Physic body. So That is the main part of the logic that you have to understand, and the following comments is going to be just the implementation and the use of these tools. So we need to create the ground. As I told you before, the ground is the place where everything is going to collide once the gravity make this happen, the magic. So in order to create the ground, we are going to get the vector 3 with the position. Check this out. The ground is 100 long in width and in depth, and 1 meter of height, the thickness. So, but if we position the ground 150 centimeters down, the top of the ground is going to be in the level zero of the y-axis. That's why we set the ground in this way. The rotation is no rotation, is that the default one, and we have 0 mass in order to avoid the movements when the things collides with the ground because of the gravity. So as you remember, here we have the material, so we created here as the last parameter, and we send the position and the rotation here, and you can see this is the dimensions of the, it says size X, size height, size depth, and 2 other parameters that configure the shadows, but this is a topic that we will see after when we'll talk about game design and other that kind of topics. So we have created the ground, and now we can just add it to the scene. As you know, this is going to add to the scene this object, so that we need to call this this method. So in order to do that, we will init physics, and then we have to add ground in this way. After that, we can see the body here, but into the physical world there is no interaction. In order to get the interaction, we need to do something similar with the renderer. We need to update the frames, update the physics and the movements, and we will do it using a module that we didn't load yet, which is update physics. This module will get the physics world that we set with init physics. As you can see, I didn't tell you, but this init physics that have the functionality of create the physics world that we are using when we update. So with this method we say something similar like 1 hour after, or a minute, 1 second after. So 1 second after the interaction between the bodies make effects, and we need to get those bodies which are collected in the Rigidbody. As you remember, here in Rigidbody we're collecting the bodies that have more mass, higher mass. So all those bodies are collected here. As you can see, we get the physics body, and we get the state. From the state we set a transform, and from the transform we get the position, and with that position we set the position of the Three.js mesh. So we get information from the physical world and we place it in the visible world, which is Three.js. And then we have the rotation too, using the quaternions. Here I put position because when you say get origin, it's hard to understand the origin is the position. So that's why I put here position. So we need to call this method into the loop. So we have to do it here, and we need to pass delta time. With this delta time, we are going to create it as we can see in the example. Check this out, like delta time. We're going to copy this, which is going to be almost the same. Now it's almost the same. So these 3 lines are these 3 lines, and we need to get the clock. The clock is up, and we need to set it in this way. So we are going to do it outside the loop. We need the 3 library, so we are going to load it. We have forget, and that's it. Now I assume there is a mistake. Update physics is not defined because I didn't load that module. Now it's done. So at this moment, this green cube is annoying me a little bit, so I am going to decrease then the size, writing .1, .1, so it's going to be 10 times smaller. Now I am going to create another physical object, but I am going to use a similar module of ground, which is physics box. It's almost the same code. It's the same code. This line is not here, doesn't belong to here. Yeah, it's almost the same. If you check this out, it's the same. The difference between them are this box has mass and had 111 dimensions, and is placed on 2 meters up from the origin of the axis in the visible world. So now are almost the same. Yeah, I will copy this in this way. Now they are really similar, and now we are going to use I'm going to use this method here, add box, physics box. It's loaded, and now because we are updating the physics, every frame is getting the information about the position or rotation of the physical world and translate it to the visible world using the object 3D that are collected on the rigid bodies that we were using when we create the rigid bodies, placing them into this. Now, as you can see, we can see the interaction between this box and the ground. As you remember, we have a tiny green box which doesn't collide with the physical worlds because it has no connection between the physical world. So now we are able to use the keyboard in order to make this yellow box move, but we are going to do it in the next video. That's all by now. Hopefully you learn or enjoy, and see you. Stay tuned.